The only problem is there's this giant sun in it here. It's like it's right here. Is there like a giant flame here? Okay. Anyway, you can see it. All right. This is called a triple point diagram. Okay. Down here, this is cut off, but this is temperature here. Okay. So this is 0 degrees Celsius. Okay. You see that point. Okay. Which is near 0 degrees Celsius. 0 degrees Celsius is simply a little bit less than that. So that point there, okay, is a little bit higher than 0 degrees Celsius. Here's 100 degrees Celsius, okay? So here's pressure in atmosphere. So instead of 100 kPa, they just use atmospheres. So this is 1 atmosphere right there. So that's 100 kPa, 101.3, right? Clear? Are you with me? Okay. Now, what does this mean? This means that these lines separate phases. This is called a phase diagram. And these lines separate the phases. Yes? You with me? Am I on there? Can you see me? Am I dark? Go like this? A little better? Okay, good. This is vapor, is blue. Yellow is liquid, obviously. And the lime green is going to be the solid. Okay, now, at 1 atmosphere, this should make sense. Follow the line for 1 atmosphere. 1 atmosphere, at cold temperatures, water goes from a solid, as you heat it, to a rather large liquid phase. Then it boils at 100 degrees Celsius. It melted at 0 degrees Celsius. See how that line there, if you draw it straight up, goes right to that point. Yes? Yes? Okay. And then above this is vapor. So it's going to be a solid. This is phase change, right? What's the change from solid to liquid? Melting, yes. Melts. And then what's the change from liquid to gas? Not evaporation. Well, you could say evaporation. That's at the surface. Vaporization, right? It vaporizes. Vaporization is when you go from the liquid to the gas. What happens when you go from a gas to a liquid? Condensation. And when you go from a liquid to a solid? Freezing. Good, 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 good. What happens when you go, look down here. Look down here. There's a little place here. See right here? There's a little place. The lines are very fat, right? But there's a certain place here where you're going from a solid. Do you have your book open? Do you have your book open? It's a little clearer to see in your book. Look at phase change 3, 4. Don't fight me here. Come on. See? There's a little place where you see where you're going from a solid to a gas. Okay? You're going from a solid to a gas. Okay? This actually should be a solid down here. Shouldn't it? Shouldn't this be solid down here? Okay? Isn't that right? Isn't that a solid down here?
Yeah.
Yeah, that says gas. That says vapor. This actually should be solid, shouldn't it? Difficulty. Yeah. Sorry. So where you can go from a solid to a gas. You see that? What happens when you, instead of going from a solid liquid to a gas, you just go from a solid to a gas? What's that called?
Sublimation.
Sublimation. It's called sublimation. Okay? It's called sublimation. Let's, I don't have green. Oh, I do have a green marker. It's called sublimation, right? Yes? It's called sublimation. Yes? So this is, let's redo this. Let's come like this. Okay? We're just going to make it a little clearer. Okay? We're going to make this all solid here. Okay? So when you go from a solid right to a gas, we call that sublimation, right? How do you spell sublimation?
S-U-B-L-I-M.
Sublimation. Okay? I don't know if you can read that. Can you read that? Can you read that? Not really well? Kind of terrible, isn't it? Okay, but we'll work on that on the board. Okay. So what happens, so when you go from a solid to a gas, a solid to a vapor, that's sublimation. What happens when you go from a vapor to a solid? What's that called?
Deposition.
Deposition. Kind of a law term. You hear that more frequently in law than as a general science student. So, deposition. Okay. Now, so that's what I wanted to show you, so we have something to talk about now. Clear? You get that? Okay? Now, I just want you to notice something. I want you to notice something. So, at very low pressure, right? Very low pressure and very low temperature, water will go from a solid to a gas. That's important. Okay. So, I have just another phase diagram. Can you see this phase diagram?
Yes.
Pretty clear. This is carbon dioxide. Okay, look down here. This is 1 atmosphere here, right? Look what happens. Solid, liquid, gas, right? So it goes at 1 atmosphere. It is going to be at very cold temperatures, right? Yeah. So this is called what? What's that called? What's solid carbon dioxide called?
Dry ice.
Dry ice, yeah. The reason it's called dry ice is because it sublimes. Look, this is negative 54, okay? But look at this. It goes at 1 atmosphere, it goes from a solid to a gas at a very cold temperature. You see that? It sublimes at negative 78.5. So if you see dry ice that's giving off clouds of what you think is carbon dioxide, and that's really not. What you're seeing when you see dry ice, how many people have ever seen dry ice? Raise your hand. And you see that smoke, right? That's actually frozen water vapor. You can't see the carbon dioxide. You can't see it. What you see is really cold air. When you're outside and it's in wintertime and you're in a northern latitude, how many people have ever been to an area where it's so cold when you breathe, you see smoke? But that's really what? What is that? That's moisture from your body freezing, right? That's what that is. Yes, you get that? It's condensation. Water vapor, freezing. Clear? Yes or no? Okay? So, that's what you see, TJ. Thank you for participating. It means a lot to me, as you know. I'm not just saying that. So it goes from a solid to a gas at a very cold temperature. Clear? So at room temperature, that's negative 56, so that's 31. So if that's room temperature, I'm really, that's like maybe the temperature in the afternoon here would be 31 degrees Celsius, yeah? So you can see that it's going to be a gas. Carbon dioxide is a gas at that temperature, yeah? Yes? That's like springtime, early morning, temperature 31. It's like over 40, it's 45, 46, 47 here in the summer. So here's like room temperatures like right here, right? So you can see that it's in the gaseous phase. You see that? Now let me change, I'm going to go off camera. Let me change this to a better water diagram, okay? And the reason I'm doing this is because it's going to be important when we talk about, somebody look up a term. What is the specific term when water sublimes? Let's say I have ice, water, okay? Let's say I'm making freeze-dried coffee. So what I do is this. I make a big giant bucket of coffee, correct? A big giant bucket of coffee. No coffee grounds, just pure coffee. I took coffee, I made it with, let's say, a French press. And I have nice coffee, right? Tastes good, doesn't it? But I have a whole bucket of it. I mean, it's the kind of coffee that's just brilliant, right? I freeze the bucket. Yes? And then I put the bucket at this is millimeters, where 760 is 1 atmosphere. 760 millimeters is the same as 100 kPa. You understand that? Yeah. Augustina, you with me? Okay. So at 4.58 millimeters, very low pressure. You couldn't exist at that pressure. And very cold temperature. Okay? Water, anything below that, just below that, colder than that, so at 0 degrees, let's say, water is going to go from, see this is a little bit better of a diagram, is going to go from a solid to a gas. What's that process called? I know that's sublimation. But what's the specific, somebody look it up. Sarge, can you look that up, please? I want you to look up the specific name of the process where water sublimes at low pressure and low temperature. And I want you to be able to spell it. Understood? So write it down. And then when we turn the lights on, I'm going to go back and I'm going to say, Sarge, what do you got? Okay? You got it? Okay, so we have solid to a gas. So below the triple point, what's the significance of the triple point? That's the point at which a substance can exist in 3 different phases. The triple point is the point at which you have all 3 phases. Anything below that triple point, when water, especially water, right, you're going to have, it's going to sublime. If it goes the other way, it's called deposition. Okay? Let's just go back quickly and look at water and look at carbon dioxide. All right, so this is the triple point right there, right? So look at that. This is atmospheres now. That's 5 atmospheres. That's 1 atmosphere. So at 5 atmospheres, at the bottom of that lake, remember on another film I talked about the lake that belched on another film? It belched and it gave up this carbon dioxide. That carbon dioxide might have been a liquid or even a solid, because 1 atmosphere is 10 meters, right? 5 atmospheres is 50 meters. What happens if it was down 200 meters? Carbon dioxide could have been what? A solid, right? Yes? Could have been a solid. Could have been a solid. Could have been a solid, right? Could have been a solid. So what? So at very cold temperatures down the bottom of that lake, I somehow don't think it was a solid. It was probably a liquid, but the point is this. Somehow I don't think it was a solid, but the point is this, that it may not have been a gas like you know it, correct? You can tell a lot from this, but at 5 atmospheres, look at this. Well, what happens if it was even more than 5 atmospheres? Right? You can see that it's unlikely because water's not going to get that cold, right? It's certainly not going to get that cold. So at the bottom of the lake, it probably was, at best, a liquid. Carbon dioxide might have been a liquid, correct? Probably wasn't a solid because of this, yes? So you see that this is atmospheres. So 73 atmospheres, you get this critical point. High temperature, well, high temperature relative to the sublimation point, 31. It's not high temperature relative to what we know, but if you're at 31 degrees Celsius and 73 atmospheres, look, you have this supercritical fluid. It doesn't know if it's a gas or a liquid. Yes? Under solid or a liquid. It has no idea what it is. Yes? Yes?
So a certain temperature, it could be either...
It could be, yeah. We don't really study the supercritical fluids because the study of that is really chemical engineering and high-level thermodynamics. Just understand this. Understand this. This is what you need to know. That at the liquid-gas interface, there exists a point called the critical point. And it's at high temperatures, relatively high temperatures, and high pressure, above that critical point, the material is very confused in terms of which state it is. That's all I want to go. I don't want to go any farther. Understood? The study of it is very complicated. Clear? And better left at chemical engineering, etc. In IB, we might discuss it, but not now. Understood? Yes? Okay. Let's go back for just one more minute. We're going to go back to this. So I'm going to talk about this. Sarge, have we found the term? What'd you find?
Phase transition.
No. Not yet. That was good though. I like that. Look up this word, guys. Figure out how to spell it. I'm not going to tell you. You ready? You ready? Listen carefully. I'm going to quit this film. We're going to go to another one. And in the meantime, you're going to look up this word. You ready? You ready? Lyophilization. Lyophilization. I'll say that once more. Lyophilization. We're out of here.